All right, ladies and gentlemen, I'm starting off with a question today, and that is, suppose you are simply just told to solve an equation for x. What exactly does that mean? Really, what does that mean? What is being asked of you when you are asked to solve an equation for x? Think about that for a second. Pause if you need to. So, what's being asked of you is that you are supposed to find all values of x that make a particular equation true. And this is really important that you understand that it's all values that you're supposed to find. And that it has to make the equation true, meaning if you were to substitute that number or numbers back in for x and then evaluate both sides of the equation, you should get the same number on both sides. Okay, that's really important that we know that. That's the key to solving any equation, really, even the really hard ones. So, let me ask you a couple questions here. If I told you that the solution to this first one was x equals 2, how would you know if I was right or not? What would you do? Figure it out. I want you to pause and figure out if this solution is right or wrong. Hopefully you paused and figured out that I was wrong. Because if we plug this back in for x, order of operations says we need to multiply before we add. And then when we add, we get 7 equals 5. Since 7 does not equal 5, x can't be 2. X is actually 1. Okay. Let's look at the next one. Same deal. I say that the answer is x equals -2. I want you to pause and figure out if I'm right or if I'm wrong. At this point, I'm assuming you've done that. And if we look at x equals -2, we kind of have a small problem with this one. We're going to square first. We get 4. We get 12. We get 10. However, we have a small problem. X equals 2 is a valid solution, but we actually have another one that works. X equals +2 would have also resulted in a correct answer. There are 2 answers. So some of this equation solving can be hard. But for right now, our goal for today is simply to recognize when we have found a valid solution. Okay? We're going to start our work with sets today as well. Sets are just simply groups of numbers. Okay? Sets in general are just groups of numbers. And a replacement set, this is something that you guys are probably not used to. Typically when you solve equations, you just find all the correct solutions. You find all the values of x that make the equation true. But sometimes we want to work in a specific set of numbers. This is the group of numbers that we want to see if they work, that we are going to use as possible solutions. So what's different here is that you're going to have a finite list of possible solutions. And then, of course, your solution set is going to be the numbers from the set above that worked. Again, from your replacement set. So the question is, why in the world would you ever want to use a replacement set? Why wouldn't you just want to find all possible numbers that worked for a particular equation? Why would you ever want to say, well, we want to find all of the numbers in just this group of numbers that work? Why would we want to do that? Again, something to think about, okay? I'm not going to necessarily reveal the answer right now. This is something that I want you to discuss in your groups tomorrow. Discuss this. Why might we ever have a situation in which we only wanted to look and see if certain numbers worked as opposed to all possible numbers? Okay, moving on. Here's an example of a problem that uses a replacement set. You're supposed to find the solution set of 2x plus 5 equals 13 if the replacement set is 2, 3, 4, 5, 6. So what this means is you want to find out if x equals any of these actually works for that particular equation. If it doesn't, you don't have any solutions. So one of the simplest things to do is just start plugging in numbers for x. And then just kind of do the math in your head. 2 times 2 plus 5 is 9. That doesn't work. It's supposed to be 13. 2 times 3 plus 5 is 11. That doesn't work. 2 times 4 plus 5, that's 13. Yay. So x equals 4 would be my solution set. Now, what if 4, for some reason, was not in there? Well, then my solution set would just be no solution. It has to be a number that appears in that particular set. Now, how do I know that 5 or 6 don't work? Well, what I'm seeing is I'm seeing a pattern in my answers. Each time I plug in the next highest number, I'm just going up by 2, and I don't think that pattern is going to change. Now, if you had x squared or you had a square root or something else that was that made it different, I think you might have some trouble. Okay? So, I've given you 2 problems, and I've told you what the replacement set is. The replacement set is 0, 1, 2, and 3. So x can only be one of those 4 numbers. I want you to figure out what the solution set would be for each of these 2 equations. Pause and then come back. Okay, so at this point, I'm assuming you've done that, and let's see what we found. So here, 8 times 0 minus 7 that's negative 7, so that one doesn't work. 8 times 1 minus 7, that's equal to 1, so that one sure doesn't work. 8 times 2 minus 7 is 16 minus 7 or 9. Well, that doesn't really work. 8 times 3 minus 7 is 24 minus 7. That's 17. That one works. So x equals 3 would be my solution set there. If you look at the next one, I won't go through the whole process with that one, but x equals 2 is going to be my solution set there, because 4 times 1 plus the quantity 3 times 2 gets me 4 times 7, which gets me 28. So that's my solution set. Again, if any of those numbers weren't in there, you would need to write no solution. If you tried all the numbers and none of them worked, you would have to write no solution. Now the question then comes, what if you got a problem that just simply says solve and you're not given a solution set? If you're not given a solution set, assume that all numbers work. Assume all numbers are your solution set. So really, you're just doing a normal equation solve at that point. You're just trying to figure out, okay, what number works. We're not getting into specific solving methods today. That's what we're doing tomorrow. Today we're just focusing on recognizing simple solutions to equations, and that's it. Okay? That's it for today. Hope you learned something new.